In the 70s, astronomers, while studying the cosmic microwave background radiation, which is the residual light from the birth of the universe, made a remarkable discovery. Our galaxy, along with everything within it, including you, is moving at an incredible speed of 627 kilometers per second through the universe. Accurately measuring the velocity of our galaxy for the first time was a significant achievement, but somewhat alarming, as no one knew for sure why the Milky Way was moving so swiftly. A large portion of our velocity can be explained by the expansion of the universe, causing all astronomical objects to move at a rate described by Hubble's law. Additionally, part of the remaining velocity is explained by the gravitational interaction between the Milky Way and our nearest neighboring galaxies, such as Andromeda. However, there was still something missing. It seemed like we were moving at a speed and in a direction that we couldn't fully explain. It was as if our entire galaxy were being pulled off course by some vast and distant object, which was, at the very least, disconcerting. But there was more. It was discovered that it wasn't just the Milky Way being pulled toward this mysterious and invisible object, but rather all galaxies in our corner of the universe. About 100,000 of them, in a region spanning over 500 million light-years, are being drawn toward this same unknown thing. This was not just perplexing, it was utterly terrifying. To try to explain this phenomenon, astronomers decided to call this mysterious object the Great Attractor. However, determining what exactly this Great Attractor was proved to be a challenging task. There is only one force in the universe capable of diverting entire galaxies from their course over such enormous distances: gravity. Gravity is created by mass. The more mass an object has, the stronger the gravitational force it exerts to attract other objects towards it. So, the Great Attractor must be something of colossal mass, a true wonder of the universe. The question that remains is, what exactly is the Great Attractor? And, more importantly, what will happen to us when we finally encounter it? Let's start by answering the first question. We typically learn about distant objects in space by pointing our telescopes at them and observing carefully. However, when astronomers first attempted to probe the Great Attractor with their telescopes, they quickly realized it wouldn't be so simple. Our Milky Way is a spiral galaxy with about 100,000 light-years in diameter and roughly 100 billion stars concentrated along a plane, about 1,000 light-years thick. When we try to peer into deep space through the plane of our own galaxy, our view is almost entirely obscured by vast clouds of dust and interstellar gas. This section of the night sky, shielded by the plane of the Milky Way, is known as the zone of avoidance and obscures our view of about 10% of the universe. And you guessed it, the Great Attractor lies just beyond that. For several decades after the discovery of the Great Attractor, its true nature remained a total mystery. We could only study it indirectly by measuring its gravitational impact on the galaxies around it. This allowed us to determine its approximate location, about 150 to 250 million light-years away, in the direction of the constellation Norma. For the first time, we had an idea of its enormous size. According to our best current estimates, the Great Attractor contains a mass equivalent to 10 quadrillion suns. At the time, this number simply didn't make sense, as nothing in our universe comes anywhere close to that size. It's nearly impossible to study the Great Attractor directly using normal telescopes, which primarily pick up light from the visible part of the spectrum. However, visible light telescopes aren't the only ones available to us. About 40 years since the Great Attractor was discovered, we've made significant advancements with both radio and infrared telescopes. With the help of these new technologies, we've finally been able to peek through the zone of avoidance to catch some fleeting glimpses of the stretch of sky containing the mysterious and massive Great Attractor. So, what did we find there? Well, it wasn't the largest black hole in the universe, nor was it an intergalactic megastructure built by an advanced alien race. What we actually found were more galaxies, many of them. Seeing what was happening beyond the zone of avoidance finally helped us understand the true nature of the Great Attractor. Scientists still don't know for sure why this structure exists, but the most common theory is that the early universe wasn't entirely uniform. There were small fluctuations in the distribution of matter. The denser regions had more mass and thus more gravitational potential. So, they began attracting even more matter over billions of years. Mass-rich regions became richer, and mass-poor regions became poorer. Gravity shaped the universe we see today, bringing together large structures and leaving behind nearly infinite voids. All indications are that due to the accelerated expansion of space-time, the distance we are from the Great Attractor will eventually begin to grow, even as our speed toward it increases. This means we will never actually reach it. It may seem strange, but that's the reality of the universe. What's your take on this topic? Follow us for more.